Ladies and gentlemen, I hope this worked this time with the technique. There's some coupling back. So ECOSUPPORT stands for Advanced Modeling Tool for Scenarios of the Baltic Sea ECOsystem to support decision making. We are 11 institutes from 7 Baltic Sea countries working with these issues. The problems today, as you all know, are large cyanobacteria blooms that are getting more and more during the recent years. And as we heard earlier today already, that anoxic or hypoxic bottom areas are increasing. So what to do about? We also have measurements about the water temperature in the Baltic Sea, and we know that it is rising. So ECOSUPPORT has the aim to, or had the aim, and now very successful, to produce a model system to combine the two different drivers, nutrient load changes, either increase or decrease, depending on the measures on land, and climate change. We have a huge bunch of models here included, from the global climate models, regional climate models, hydrological models, models for atmospheric position, and several models for the Baltic Sea chemistry, even for the food web. The idea is each of the models is not perfect. You know that if it would be perfect, then our knowledge of the nature would be perfect and we need no science money and no bonus anymore. So the idea was to use several models to illustrate or to quantify the errors. And here's the result. It shows the volume average temperature and volume average salinity for the Baltic Sea from 1960 to 2100. The solid curves are the ensemble mean actually of 10 simulations. The dotted and dashed lines indicate the ensemble spread by the ±1 standard deviation, so the uncertainty somehow. Projections, I call it, or scenarios, these are not predictions, because it is very important to define what are the assumptions behind. And in this case, it's an A1B scenario actually from the latest IPCC report in 2007. What will happen under these climatic changes with the Baltic Sea environment? And here we have the bottom oxygen concentration in the Baltic Sea. It's the status from 1850, reconstructed with the model. And now in the animation, you see year by year how the situation changed according to changing climate and changing nutrient loads. During the first part, it's of course the large increase in nutrient supply from land to the sea, that the colors change from more blue to red to finally black. In the later period, we actually in this simulation have not assumed an increase in the nutrient loads compared to today. But this is then the effect of the warm water, basically. What information is then available from this model system that we have developed in ECOSUPPORT? Something like this that is of high relevance for HELCOM. The water transparency changes in terms of satiety depth changes between the end of the century compared to present climate. It is now important to define what kind of nutrient load scenario you assume, together with the warmer climate. To the left, you see the Baltic Sea Action Plan, as published in 2007. Then we have the current legislation, for instance, the wastewater directive. The ref is the reference case, assuming today's nutrient loads. And then we have a case called business as usual, following an exponential increase in agriculture in all Baltic Sea countries, following the example of Denmark. So a net large increase of nutrient supply. So these different choices you can make as a decision maker, and you see the model will give you the result. Again, each of these panels are not one model. It's an ensemble of 10 different runs, different climate projections, and different climate, different Baltic Sea models with different biogeochemistry. You see that the Baltic Sea Action Plan is actually not so efficient. The colors are green, so a few centimeters, decimeters improvement in the Baltic proper, where on the other hand, the business as usual show a decrease in the seashore depth of more than a meter in the southern Baltic proper. What will then happen with the higher trophic levels? The cod, for instance. The cod reproductive volume will, according to what we learned earlier, because the salinity is going down, decrease in future climate. But there's also the question about the food. You have two different scenarios here in the two lower panels, the reference and the Baltic Sea Action Plan. Cod biomass as a function of time or in different time slots. You see overall the cod is going down. But in the 2050s, in the reference case, you see an increase according to this modeling, and this is due to the fact that more food is available. Coming to the highlights from ECOSUPPORT, we have generated a large database describing past and future climates, which is available for stakeholders, policymaking. Climate change may have considerable impact on the marine environment with socioeconomic implications. There are actually several drivers. One is the warmer water temperature that cause the oxygen saturation concentration is lower. The other one is that remineralization in warmer water is faster, so more of the nutrients that are stored there in the sediments are released in the water column. So somehow we are punished for the situation some decades ago. Finally, there's a flashing out of nutrients from land. And the third highlight is nutrient load reduction, and sustainable fishery may even be more important in future climate than in present climate, because these climatic effects partly counteract nutrient load reductions. So it is really something, a challenge for stakeholders. Thank you. Thank you, Fred.